Okay, so let's get into some of the setup information, and like I said, particularly for the people who have to generate accurate flat patterns. A lot of times the designers don't really need to. We'll just use a K-factor to determine the flat pattern. But there's three ways that SolidWorks uses, three calculations it uses for determining the accurate flat pattern. That's bend allowance, bend deduction, and K-factor. There's oftentimes a bunch of confusion between what's the bend allowance and what's the bend deduction. The screenshot you're seeing here is right out of the SolidWorks help file, so it's pretty easy to understand the difference between the two looking at this. So what they're talking about with the bend allowance calculation is, you know, your total flat length is equal to the flat sides here up to the tangent of the radius. So we add those together and then simply add the bend allowance. Now, how do you determine the actual bend allowance value is more of the challenge. There's information in the machinery's handbook regarding that. And even our sample tables seem to be fairly accurate with that information. The bend deduction is, you know, it's kind of a similar type of a calculation. It's actually measuring the lengths all the way out to the virtual sharp to the corner, and then you subtract the value called the bend deduction. So that's pretty straightforward. Then there's also the K-factor. Oh, and one more thing about this. Obviously, what this means is that if your part has several different bend radii in it, you're going to have to know what that bend allowance or deduction is for each different radius. So that could be a lot of information that you would have to input. And on to the K-factor. So this technique is used oftentimes across the sheet metal part that has lots of different bend radii in it, because it'll just make the same calculation for all of them, and oftentimes this carries plenty of accuracy for certain types of parts. Anyway, this is again out of the help file. You'll find this screenshot here if you need further explanation on how that's calculated. The other thing I want to cover is what we call bend tables, and bend tables are particularly useful if you are using a bend allowance or bend deduction to determine your flat patterns, and your parts have, you know, you have parts of different thicknesses, and then of course you might have different radii within those parts. So there's sample bend tables that are provided with SolidWorks, and they're in this location at the bottom of my screen. It's really just your SolidWorks install directory, and there you'll find, under Lang, English, you'll find a folder called Sheet Metal Bend Tables. So there are a bunch of sample tables in there. Then you have a bend calculation. It's not really a table. I'll show an example of that, but it's a way to calculate your bends using an equation. All right, so here's a sample of a bend allowance table. There's header information, and then material type that this is for, and then as you can see, it's really just a table of radii here, thicknesses across the board, and then the bend allowance typed in here. And this is a print of the sample one, and it tells us here that it really is extracted from the machinery's handbook. I would still verify those values. Then there's the bend calculation technique, and so this is, again, it's just really an Excel spreadsheet, but it's not a table. It's the information down here is what it's going to use for basically saying, for example, any bend from 0 to 90 degrees, use this formula to calculate the flat, and so on. Gauge tables are another great tool to make it convenient for setting up the thickness and allowable bend radii within a part. The key thing about using a gauge table is it can only determine the flat pattern by the K-factor specified in the gauge table. The default sample gauge tables are again in Lang, English, and you'll see sheet metal gauge tables. Okay. Here's a sample of what that looks like. So again, some header information, K-factor, that's important, it's sitting right here in the gauge table. And then the only thing really contained in the gauge table is just the nomenclature for the gauge, the thickness it's going to use to thicken the SolidWorks part, and then available bend radii. These will all be available, the gauge and the radius, as pull downs within our base flange parameters when you're creating the part. So it makes it really convenient to set up standards for your users so that when they do want a certain gauge, it is using a precise thickness of some kind. Then we have another table. It's kind of like the gauge table. It's a combination of the bend and gauge table, and the advantage here is you can have choices of gauge thicknesses, bend radii, and allowable or bend deduction, bend allowance or bend deduction or K factor specified, not just the K factor. And it's in the same location as the other gauge tables, the samples. And that one is formatted completely different. It looks like this. So you'll see the gauge as sort of a heading, and then the thickness for that gauge. Then you'll see angles, and those angles will be available as pull downs in the menu for the user. Same with the radius. And then here is the bend allowance for each of those combinations. So a little bit different, providing a lot of automation, a lot of standardization in company environments. The next thing that's really important, if you are using these tables and you have multiple users, you want to make sure that those are on a network shared location, and then go to your tools, options, file locations within SolidWorks, and specify the locations of your sheet metal bend tables and gauge tables so everyone is using the same information.